In this video, I'm going to explain Kirchhoff's rules. I've also heard it pronounced Kirchhoff's rules. In any case, essentially, he just came up with two rules, which I feel like, if you understand Ohm's law, are pretty self-explanatory. But I'm going to go over it anyways, just in case anyone has a stickler for a teacher. So his first law is basically, or rule is called the Junction Rule. And essentially, if you've looked at any circuits where there's a split, such as there's a battery here and it comes in, and then there's this, it goes two ways, and it comes back together and goes around and whatever. Here's two resistors, R1, R2, and there's a potential across here, change of potential. The junction rule states that at any junction, the sum of the currents will be equal to 0. So the sum of I must be equal to 0. That is to say, if we have a current coming in and it splits, I must be equal to I1 plus I2. If you add all those up, if you get them all to one side, it's I minus I1 plus I2, and that has to be equal to 0. Good way to check yourself if you're doing Ohm's law, just follow the junction rule. For number 2, it's called the loop rule. And what that means is if there's any closed system, or like a closed loop, so there's a battery, basically what we have right here. If there's a battery and whatnot, the sum of the potential differences around any closed circuit must be equal to 0. So, change in potential must be equal to 0. So if we have the change of potential has to be equal to the change of potential 1 plus the change of potential 2. Minus them all over. Whoops, that should be a minus. Has to be equal to 0. Might come in handy if you have this. So we have two resistors, R1 and R2. There'll be a different potential difference. The constant current, there'll be a different change of potential between this guy right here and this guy right here. Although they're in series, yes, there'll be a different potential difference across them. So, and the change of potential here, we'll call 1, change of potential here, 2, has to be equal to the total change of potential. That's basically what the loop rule means. I didn't really find that rule was very difficult to understand. There's another idea that kind of goes with that. And positive and negatives matter, I guess, in his rules. So if we have a circuit, or part of a circuit, we have this resistor here. We call this I positive the direction, and then we have, it comes around, and here's a battery. And the different change of potential will be equal to IR. But it'll be negative IR because you're dropping potential. You're going from V to a lower V. Basically, then, if you have a change of potential and equal to positive IR, you know that they're going the opposite direction of the high potential to low potential. They're going from low potential to high, so there has to be a power increase. I don't really see this is that big of a deal, but might be. I've read and read and read, and I still can't figure it out. The final real thing I have to say about this is anytime you're trying to solve a problem, the number of equations you'll need to solve the problem using these two rules essentially means that you'll need as many equations as you do currents. That is to say, in this equation right here, you'll need two equations to solve the problem because you have three equations to solve the problem because you have three different currents. If you have more, you'll need more. This becomes really terrible later on, but this is just a slight thing that Kirchhoff hit off on. Hope this helps kind of explain his laws. Most of the books I read, a couple don't even cover it. The two that do cover it are just kind of, one's a chapter. One goes into it pretty in-depth, but I don't know. So I hope this helps. Feel free to visit my website. Send me some suggestions. If you want help, I can help you. Thank you for your time.